Welcome back, NCEA Level 1 physicists and earth space scientists, continuing on with the energy external, and today looking in more detail at electrical energy generation, which we touched upon in the previous lesson. So in terms of energy resources, there's two types of resource, renewable and non-renewable. New Zealand is blessed with a large number of renewable energy resources, which are resources that do not run out. So they include wind, hydroelectric, wave, tidal, solar and geothermal, and we'll look at those in a little bit more detail in this lesson. Fossil fuels, however, such as coal, gas and oil, as well as uranium, which is used in nuclear energy, are non-renewable energy resources because they do run out. And we'll also look at a few of those examples in today's lesson. So looking at wind power, here's a wonderful shot of the wind farm in Makara in Wellington. So what happens is that the wind, the kinetic energy of the wind, is used to rotate a turbine, which again moves, and that in turn uses an electrical generator to generate electricity. So the kinetic energy is basically being changed into electrical energy, kinetic energy of the wind via a turbine. That's the energy change. In terms of hydroelectric power, which is quite common in the South Island, what happens there is the gravitational potential energy of the falling water is used to drive a turbine, which then rotates an electrical generator as the water moves through, kinetic energy. So you've got the gravitational potential energy of the height of the water. Then as it goes through the dam, that's then transferred into kinetic energy, which is then transferred via a generator into electrical energy via that turbine. You see that image here. So again, you've got the water in the reservoir dropping, going through the penstock, okay, where the water starts to move. That moving water then goes through the turbine moves, so again kinetic energy, and that kinetic energy is then transferred into electrical energy via a generator. Next we have wave power, not so common in New Zealand. I've seen it being used in Portugal and in Spain, where this time the waves of the ocean, kinetic energy of the ocean can be used to drive the electrical generator. So again, the kinetic energy moves the turbine inside the wave generator, which then converts that or transfers that into electrical energy. Next is tidal power. So in tidal power, this time the moving water, again kinetic energy, of the incoming and outgoing tide caused by the tides, is used to drive a turbine again, which rotates and then generates electricity via a generator. So you've got the gravitational potential energy, because remember you've got high tide, low tide, there's a height difference, which is then transferred into kinetic energy, and then that's again transferred into electrical energy via the turbine. And that's a little bit more detail there, where the tide's coming in, the water rushes in, and then as the tide comes out, due to the height difference, as you can see, that's the gravitational potential energy, which is then transferred into kinetic energy as it moves through the turbine, turns the turbine, and that generates electrical energy. Next, quite common in Rotorua, in the volcanic areas top of the North Island, where the hot water and steam rise to the surface, as you see in the image there. Again, that steam is then used to drive turbines, so you've got the thermal heat energy causing movement up, which is kinetic energy obviously, and then the turbine basically starts to move and transfers that into electrical energy. So this is known as geothermal energy. Next one is solar heating, where this time the heat energy of the sun is focused onto pipes which contain water. Okay, so that's the thermal energy. The water starts to boil. Okay, so it starts to move because the gas obviously starts to move more than liquid. So kinetic energy, which then drives the turbine. See the theme here, which then generates electrical energy. Then solar panel power, which is quite common in Marlborough. Even myself, I have solar panels on my house. So in that particular case, the light energy is being basically transferred into electrical energy. Okay, so you're basically producing electrical energy directly from the sun's light radiation. And then looking at fossil fuels, which is a non-renewable resource. Okay, so coal, oil and natural gas. So they've been formed under the ground by dead organisms, which takes a lot of time. That's why it's non-renewable. So Huntly Power Station near Hamilton is an example. So in that, Indonesian coal is burnt. That produces heat. Okay, so thermal energy. which then starts to heat water, which again steam. Steam begins to move, kinetic energy, which then turns a turbine, which generates electrical energy. Okay, and that's exactly what we see in the Huntly power station. You've got the chimney stack, which is all the combustion products, but basically you've got the furnace, which heats the water in the pipes, which moves the turbine and generates electricity. And you can see there you've got that cooling tower, which is quite common to see, those two cooling towers in Huntly, which releases the excess water vapour. So those are some ways that electrical energy is generated in Aotearoa, New Zealand, and also other parts of the world.